Hello everyone. Today I am glad to show you how to use LoadMaster to design and optimize a loading plan. First, we open the browser. I recommend you use Google Chrome, which has the best compatibility. Now we enter the URL, enter the login page of LoadMaster. Fill in your company's tenant name here, and enter your personal username and password. Click Login to enter the task page of LoadMaster. Now I will demonstrate how to use the LoadMaster to load multi-type cargoes into containers. First, we click the Multi-Cargoes button under the Loading Container task type, then we will go to the page for designing the task. Now we see the basic information page. We can set the name of the loading task here. The name is generally a unique code, which is convenient for identifying the loading plan, such as the purchase order number, or the waybill number, or the customer name. Now we start to design the plan. In the first step, click the Cargo button on the left side to enter the page for cargoes. Due to the large number of cargo types, we can import the packing list data using bulk importing. Now, we click Add Cargo, Get Excel Template. You can see that the template is being downloaded at the bottom left corner. We open it, and in the middle of the Excel, there are some descriptions for this template. You can freely delete it. To fill in the template, we should pay attention to some rules. The first 6 columns are required. The name can be defined as a unique code for easy identification, such as the material code. The quantity refers to the number of wooden boxes, iron boxes, or flat pallets. The length, width, height, and weight of the cargoes should be consistent with the measurement unit defined in the template. The default measurement unit in the template is centimeter and kilogram. In addition, the weight here is the gross weight of a single box, or gross weight of a single flat pallet. Now I open the template that I have processed before. You can see that the name, size, and weight of the cargoes have been filled, and the length unit has been modified to millimeter. Now we fill in other parameters according to the demands of your company. Because it's important for you to avoid placing heavy cargoes on light cargoes, we should set up loading capacity. The loading capacity is integer. If the loading capacity of a cargo is larger, it has stronger ability to support other cargoes, and can be placed in the bottom of the container. According to your demands, the load capacity should be the weight of the cargoes. As the weights of the cargoes is usually not integer, we need to use the int function to fill in the load capacity. If you need to specify the order of loading different cargoes, please set up the spatial order. The space order is numerical value. The larger the value, the earlier it will be loaded. If you need not specify the order, no setting is required. Now let's take a look at the setting of the cargo placement method. In default, the 6 placement methods are all allowed in the template, so we only need to set the disallowed placement method to 0. We can set the Allow column of the allowed placement methods or keep the column unset. In terms of automobile accessories, generally only the height direction of cargoes can be perpendicular to the ground. The corresponding placement methods in the software are stand and rotate. Therefore, we need to set the following 4 placement methods to 0, which means that these placement methods are prohibited. It should be noted that the size of the box of automobile accessories usually has a certain modulus relationship with the size of the container, that is, the direction with the size 114 centimeters should be consistent the width direction of the container. So, we need to screen out the goods with size of 114 centimeters. We set the cargo with the length of 114 centimeters to only allow stand and rotate, and set the cargo with the width of 114 centimeters to only allow stand. Now we can ensure that cargoes with size of 114 centimeters are placed in 2 rows along the width direction of the container. After filling in the template, save it and return to the software. Click Add Cargoes, Import from Excel, select the template you just filled out, and you can see that the data of the packing list has been successfully imported into the software. Now we briefly introduce the order form mode in batch import. It needs to import your frequently used cargoes, perhaps thousands of cargoes, into the software's cargo database for one time. When designing the loading plan, you only need to fill in the name and quantity of the cargoes in the template, and you do not need to fill in the information such as the size, placement methods, and loading capacity. For detailed operations, please see the video Database Initialization. Now we can see that, after the cargo information is imported, the upper right corner of the table shows that there are 84 kinds of cargoes to be loaded this time, with a total volume of 437.74 cubic meters. Next, we click the Container button on the left side of the page to enter the page for containers. Click Import from Database. In the pop-up window, select the commonly used 40 HQ and 20 GP of your company. Note that the default quantity of containers in the last column of the table is 100,000, which means that the software will automatically select the appropriate container type according to the current loading task, and calculate how many containers should be used. If the number of a container is set to 1, this container will only be used at once. Now we click plus symbol at the front of the table to see the size information of the container. Here, 2 points need to be explained. The first point is the reserved size. Forklifts are usually used to load automobile accessories, and the door frame of the container has a height of 10 centimeters. So, we need to reserve 10 centimeters in the height direction for the forklift operation. The second point is if the container has some limitations for the weight of loaded cargoes, please fill the maximum load weight of the container. Next, click the Loading Rules button on the left side of the page to enter the rule setting page. On this page, you need to pay attention to the settings of the following parameters. The first is the placement interval. In the actual loading operations, there are inevitably gaps between the cargoes. So, we need to define the length and width of the container. Forklifts are usually used to load automobile accessories, and the gap between cargoes is large. So, when using the software for the first time, it is recommended to set the gap between cargoes to 1 centimeter in the direction of width and length. In addition, the value of the automobile accessories is high, and we should ensure the safety of the cargoes. So, we can set only cargoes with the same length and width are allowed to stack on top of each other, so that the gravity center of the cargo is more stable, but the volume usage rate will be slightly reduced. If we need to specify the loading sequence of cargoes, we not only need to set the spatial order of cargoes, but also the cross depth. Cross depth is a further constraint on the 2 loading rules, spatial order, and place the same cargoes next to each other. It is often used with the 2 rules. So, what is the cross depth? Now let's look at a picture. You can see the 3D picture on the left. There is free space at the junction of different cargoes, but they are not mixed. This is because cross depth is 0, and the volume usage rate of the container is 88%. Let's take a look at the 3D picture on the right. The cargoes are mixed at the junction of different goods. This is because the cross-depth value is 1 meter, and the loading rate has been increased to 92.46%. In general, the larger the cross-depth value, the higher the volume usage rate. If we need not consider spatial order, or place the same cargoes next to each other, we can ignore the setting of cross-depth. Next, click Optimize, and the loading plan will be generated in 1 second. As you can see, the left side of the page shows that this plan uses of 840 HQ and 120 GP. Now we review the plan. First of all, let's see if the plan ensures that heavy cargoes are not on light cargoes. We click on the play button at the top left of the 3D image, and review the plan from the first step. You can see in the upper left of the 3D picture that the weight of the cargo loaded in the first step is 973.368 kilograms, and the weight of the cargo loaded above it is 564.12 kilograms, which guarantees that the heavy cargo is below, and the light cargo is above. Using the same methods, we can check whether the stacking of cargoes in other steps is reasonable. Next, we click Balance Analysis on the right side of the page to view the gravity center of the container. If it is a maritime plan, we can analyze whether the gravity center of each container is within a reasonable range. According to the experts' recommendations, when lifting the container at the wharf, and the weight of the cargo loaded in the container is close to the maximum weight of the container, the gravity center shifting of the cargo should be controlled within 10% compared with the gravity center of the container. In this condition, lifting will not damage the cargoes. If the total weight of the loaded cargoes is significantly lower than the weight limitation, the gravity center shifting can be slightly more than 10%. Now we click to the name of each containers to view the gravity center. You can see that only the gravity center of the 6th container has a large shifting, and the other containers have met the gravity center balance requirements. As for the 9th container, because the cargoes this time have been completely loaded, there is a lot of idle space. At this time, we adjust the shipping plan and add the subsequent batch of cargoes to be shipped together, which not only reduces the cost, but also ensures the gravity center balance. In addition, if the 9th container cannot add the cargoes to be shipped in the next batch, then we can move some of the cargoes in the 6th container to the 9th container. So how to solve the problem of unbalanced gravity center of 6th container? We can manually edit the plan. For detailed operations, please see the manual editing video. The above is an introduction to the gravity center balance. Next, we will demonstrate the fixed recalculation function, which is commonly used in the loading of automobile accessories. That is, fix some satisfactory container loading plan, and redefine the loading rules and calculate the plan for the other containers. Click Final Loading Stage on the left side of the page, and fix the satisfactory container loading plans in the table of loaded unit list. Then, according to your ideas, modify some relevant rules in the page Loading Rules, Cargoes, or Containers. Finally, click Optimize, the loading plan will be recalculated, and new suffix will be added after the name of changed containers. Now, after the plan is reviewed, we can share the plan to the mobile phones and guide the on-site loading. You can also generating loading report for data analysis. For details, see the video of Paperless Operation Guide and Report Analysis. For more terminology, please refer to the user manual. If you have any questions, please send an email to annie@zhuangxiang.com, and we will answer you as soon as possible. Thank you.